Hello, this is David Lance, and I want to welcome you back to this third in a series on climate change of defending the American way of life. In our first video, I looked at what I called God and Gaia. In the second one, I looked at the climate change con job. And today, I want to look at the science behind what I call the climate change hoax. Now, in the previous two videos, we discussed how the Gaia hypothesis inspired a vague philosophical religious movement, and then that went on. The movement led to the needed environmental improvements that were needed in the 70s and the 80s and the 90s. But now what we're finding is that special interests have conned taxpayers out of billions of dollars for what is called the Green New Deal. And so you might recall that in a previous video, I talked about a book by Michael Crichton called The State of Fear, in which he states, quote, the politico-legal media complex is dedicated to promoting fear in the population under the guise of promoting safety. And certainly a few years ago, Congresswoman Alexandria Ocasio-Cortez said, quote, the world is going to end in 12 years if we don't address climate change. And your biggest issue is how are we going to pay for it? And so those are the sorts of things that we covered in the last section on the climate change con job. Now, today I want to discuss what happens if mankind was not the cause of climate change, according to the science. And so here's an outline for today's talk on the various issues I'm going to cover. First of all, I think it's important to spend a little time to discuss what do we mean by climate change or / global warming. Second, how do carbon emissions cause climate change exactly? We hear a lot about reducing our carbon footprint. Third, did you know that 0.04% of the atmosphere is made up of carbon dioxide? And if that's the case, how does carbon dioxide drive global warming? Another question to ask is, what are the effects of climate change, at least according to the people that believe that mankind is causing it? Fifth, and very importantly, has Earth ever experienced climate change in the past? You see, I believe that climate change happens. I'm just not a fan of the idea that humanity is the cause. And so if climate change has happened before mankind even existed, what else besides humanity is the cause of climate change? There's a researcher by the name of Heinrich Svensmark and Nigel Calder who have written a book called The Chilling Stars, A New Theory of Climate Change, that I'll demonstrate a little bit of their ideas from. Well, let's get started by talking about what causes climate change or global warming, at least among those people who, like Ocasio-Cortez, feel that we need a Green New Deal. Now, basically going from NASA's Global Climate Change webpage, we read, quote, global warming is the long-term heating of Earth's climate system observed since the pre-industrial period between 1850 and 1900 due to the human activities of primarily fossil fuel burning, which increases heat-trapping greenhouse gas levels in Earth's atmosphere. I'm fascinated by the fact that we didn't bother to think of looking before the year 1850 and that we only wanted to look at it due to human causes. They go on to write that the term is frequently used interchangeably with the term climate change, though the latter refers to both human and naturally produced warming changes. And so here's a graph that looks at global warming going from the 1880s up until the year 2020. Now you'll see that they're basically starting at a 0 point in degrees Celsius. And so they show that there's actually a little bit of a cooling trend, it looks like, got down to declined by a half a degree Celsius by the year 1910 or thereabouts. And then it started a long march up, especially from 1940 up to the year 2020. So we had about 0.7 of a degree increase in Celsius. Now, this graph is an example of what is sometimes known as the hockey stick graph. And right now, as I do this in June of 2021, here's the head of the hockey stick, and here's the handle going up there. And so there's that hockey stick thing. I'll have more to talk about that in a minute. I thought it was also important to mention that there are other types of gases besides carbon in the atmosphere that contribute to climate change. Scientists attribute global warming trend observed since the mid 20th century to the human expansion of the greenhouse effect. And again, I'm quoting from the Global Climate Change page for NASA. Warming that results when the atmosphere traps heat radiating from Earth toward space. Certain gases in the atmosphere block heat from escaping. Long-lived gases that remain semi-permanently in the atmosphere and do not respond physically or chemically to changes in temperatures as the Earth temperatures change and so forth. And so gases such as water vapor, which respond physically or chemically to changes in temperature, are seen as feedbacks. And so here are the molecules that are important for this whole thing. Now, from this gentleman, Johann Kushner, working with Columbia Climate School and the State of the Planet publication, here's the source right there. He says that Earth absorbs energy from sunlight, but as the surface warms, it also emits energy in the form of infrared radiation, which we know as heat out into outer space. Water vapor and CO2, however, act like a cap, making it more difficult for Earth to get rid of this energy. Now, they go on to write, and here's the source, that CO2 is only 0.04% of the atmosphere. That's all on this website here. While water vapor varies between 0 and 4% of Earth's atmosphere. But while water vapor is the dominant greenhouse gas, it has windows that allow some infrared energy to escape without being absorbed. And that's where CO2 comes into play, because it can be in the atmosphere up to 50 kilometers. And that's roughly 32 or so miles up into the sky. Here's a really important point I want to note. He writes, the burning of fossil fuels affects the concentration of CO2 in the atmosphere. But before the Industrial Revolution, the amount of CO2 in the atmosphere was about 288 parts per million. That's what ppm stands for. We have now reached about 414 parts per million. So we are on the way to doubling the amount of CO2 in the atmosphere by the end of this century. Scientists say that if CO2 doubles, it could raise the average global temperature of the Earth between 2 and 5 degrees Celsius. Now, keep that in mind. You'll see that since 1940, we've increased by about 0.7 degrees Celsius. Based on that other graph. And so the World Wildlife Organization, basically echoing Ocasio-Cortez, has written its publication that, quote, more frequent and intense drought, storms, heat waves, rising sea levels, melting glaciers, and warming oceans can directly harm animals, destroy the places they live, and wreak havoc on people's livelihoods and communities. As climate change worsens, dangerous weather events are becoming more frequent or severe. Those are the effects of climate change. That's why AOC is so concerned about all of that and wants to spend billions of dollars on it. Now, perhaps you don't recall something called ClimateGate. It had to do with release of emails by scientists in England back in the year 2009. Now, there's a scientist by the name of Larry Bell, who in 2014 wrote an article. That's why you're warned that this article, by the way, is 7 years old. But then the issue that he's writing about happened in 2009, which was, 11, almost 12 years ago. At any rate, his title of his article is Global Warming's Three-Ring Circus Brings Us to the Costliest Show on Earth. Now, they focus on this UN Intergovernmental Panel on Climate Change, IPCC, which did a 2001 report. And they said, based heavily upon data taken from tree growth rings in the Yamal Peninsula in Siberia, it indicated that world temperatures, which had been stable for 900 years until the 20th century, suddenly soared due to human fossil fuel burning greenhouse gas emissions. At least that was what the IPCC's story was. But when some scientists reviewed the emails that had been released and so forth, they found that the Yamal tree samples came from only 12 specimens out of 252 in the data set, while a larger data set of 34 trees within the same vicinity that weren't used showed no dramatic recent warming, but was in fact there was a warmer temperature during the Middle Ages than had been shown on the other things. And so he's questioning the validity of using the tree rings and the small sample on which to base this. I remember reading that the tree sample data, the original data, is now gone. We can't figure out what really happened. And so there was a guy named Mann who basically created a 1,000-year-long graph that was cobbled together using various proxy data derived from ice cores, tree rings, and written records of the growing season that dates up until the year 1982, where it then switched to using surface, that is ground station temperature data that was recorded after that. The question is, why the change in 1961? Some theorize that maybe it's because that's when the other tree ring proxy data calculations by two scientists, Keith Briffa and at the East Anglia University Climate Research Unit, began going the other way in a steady temperature decline. Now, what they wanted to show was an increase in temperature, but doggone it, the tree rings were going in the opposite direction, so they switched their data sources, is what he's saying. Now, another question is, has the Earth ever experienced climate change in the past? And so this is from acs.org. And so we have this graph. Now, the black line on the graph shows the variation in the atomic composition of the ice cores that they looked at. And those ice cores essentially tracked back to 650,000 years ago. So essentially, we're recording this in thousands of years. So 100 on this scale is actually 100,000 years. And that means each of these little tick marks is 20,000 years. And so here there was a spike in temperatures around about 120,000 years ago. Here's a smaller spike today. And so we can also then, in the red line, that shows carbon dioxide in the air trapped in the ice cores. And so here's what the ice cores have been more recently. Here's what they were back 120,000 years ago, and so on. And so one of the things that people who say that the climate change is happening now due to greenhouse gases from man-made pollution is that it's just happening faster than it used to be. Well, here's a period of about 220,000 years ago where the change in temperature occurred very rapidly, much more so than in the more current time frame. You can see that lasts a longer time period than it does there. ACS, by the way, stands for the American Chemistry for Life, American Chemistry Society. Now, I should tell you that I have a master's degree in public affairs from the School of Public and Environmental Affairs at Indiana University, and with about half of my graduate degree in quantitative analysis. And today, as an adjunct instructor, I teach college-level statistics. And so one of the things about research and using statistics is that we need a theory to show why we might say a variable A causes reactions in another variable called, say, B. And so one of the things that we've seen so far is that we've seen how increased CO2, carbon dioxide, they say causes climate change. But the only evidence that we have, and this truly is the only evidence that we have, is that they happen hand in hand. They seem to go hand in hand. But in statistics and research, we know that correlation does not necessarily imply causation. In other words, we need a theory that is testable so that we can demonstrate that increased X causes climate change. What exactly is, and the scientific word is mechanism, what is the mechanism or the thing that makes increased carbon dioxide affect temperature? For example, we might say that because we have fewer pirates than we used to back in 1820, that's the cause of global warming. So here we can see that global average temperatures were only at about 14.3 centigrade back in 1820 when there were 35,000 pirates. And today they're about 15.8 degrees Celsius in the year 2000 when there were 17 pirates. It was probably all 17 pirates that took that one oil tanker captive that Tom Hanks played in a movie about that, playing the captain. I don't remember the name of the ship, though, or the movie for that matter. Now, There's a professor by the name of William Happer, and he gave a speech on the effect of CO2 and Earth warming. And so remember that statement earlier that I read to you about how CO2 in the atmosphere had been 288 parts per million, that we've now reached a level of 414 parts per million. And so we're on the way to doubling CO2, and that will lead to an increase in temperature between 2 and 5 degrees Celsius. We've quoted that. I mentioned Joachim, whatever Joachim's last name was, and so forth. Well, Happer is the Cyrus Fogg Brackett Professor Emeritus, that means he's retired, in the Department of Physics at Princeton University, where he received his PhD. He's a fellow of the American Physical Society and the American Association for the Advancement of Science. He has served as the co-director of the Columbia Radiation Laboratory, director of the Energy Research in the U.S. Department of Energy, and for our purposes, most importantly, he was the founder and first president of the Carbon Dioxide Coalition. So he must know something about CO2. So I have a video that I want to play. It's actually from a 56-minute long speech he gave in February of 2021. We're only going to listen to about 3 minutes of that speech. And so I want to make sure that everything is working. Yes, it is. So here we go. Let's play it.
Planck was the first one who was able to show why the radiation from warm bodies has the shape it has. On this picture to the left of Planck and below is Schwarzschild, I'll have more to say about Schwarzschild in a minute, is a smooth blue curve. And what that is, again, left to right is wavelength, or the frequency in this case, of light, thermal radiation, and up is the thermal power that's going out to space. And so if there were no greenhouse gases, the radiation going to space would be that Planck curve, that blue curve there. And that would be the radiation that keeps the Earth cool. In fact, that's not what you observe if you look down from a satellite, and we have lots of measurements now. What you see is something that looks a lot like the black curve that's below, with lots of jags and wiggles in it. And that curve was first calculated by Carl Schwarzschild, whose picture is below Planck. Carl Schwarzschild was an officer in the German army in World War I, and he did some of his most creative work in the trenches on the Eastern Front facing Russia. And he, in fact, produced one of the first analytic solutions to Einstein's general theory of relativity while he was there, on the front lines. And alas, he died before he got home, not from Russian bullets, but from an autoimmune disease, which was really tragic. But anyway, Schwarzschild was the theorist who figured out how to calculate how the real Earth works with greenhouse gases in it. It's those jagged black lines. Now, the important point here is that you notice there's also a red line on this chart. What the red line is what would happen if you double the CO2 concentration from today's level. So right in the middle of these curves, I'm sorry I don't have a laser pointer here, but you can see a gap, and that's due to CO2 absorbing radiation that would otherwise cool the Earth. If you double the amount of CO2, you don't double the size of that gap. You just go from the black curve to the red curve, and you can barely see the difference. So the message I want you to understand, which practically no one really understands, is that doubling CO2 almost doesn't make any difference. It goes from that black curve to the red curve. And on the basis of this, we're supposed to give up our liberties. We're supposed to give up the gasoline engines of our automobiles. We're supposed to accept dictatorial power by Bernie Sanders and Ocasio-Cortez because of the difference between the red and the black curve.
And so there you have it. The doubling of CO2 does not really do anything at this point to temperature. And so there's another set of videos. I've got 3 in a row here that I want to talk about next. And so it's from this gentleman, Henrik Svensmark, who wrote the book, The Chilling Stars, A New Theory of Climate Change. Now, this particular video is over 50 minutes long, and I've selected 3 snippets that I will look at that hopefully give you a good picture of what he's talking about. He's interviewing astronomers, oceanographers, people with statistical knowledge, people with geographic knowledge. And so it's a variety of sciences that have come together to help him pull together this. And he's actually going to do an experiment in the 3rd video that says that what is the mechanism for causing climate change. So let's watch this video now.
What's fascinating is that this Milky Way, which looks something which is very far away, it isn't very far away. We are part of it. And this link between this Milky Way and us is cosmic rays.
The solar system moves in and out of the spiral arms. And the spiral arms are the regions where you have the new stars. And the new stars is also some of them the heavy stars that live very shortly and explode in supernovae. That means that you have more cosmic rays as you move in to the spiral arms.
If we look at the Milky Way from the top, what we'll see are 4 spiral arms, and that's because the Milky Way is a spiral arm galaxy. So we have 4 spiral arms. We are located here on some small armlet. We are rotating around the sun once every year, but the whole solar system rotates around the Milky Way once every about 250 million years. That's 1 galactic year. What this means is that every 150 million years, when we pass through a spiral arm of the galaxy, it's colder by something of order 5 degrees or 10 degrees. When we're outside of a spiral arm, it's hot. Now we're on this small spur, so we're witnessing cold weather.
Okay, that's the first of 3 videos. Let's watch this one now.
It may sound strange to most people that we're talking about icehouse conditions today, but if you look on the long time scale, you find that during most of Earth's history, we didn't have any ice caps whatsoever. Today we have. 450 million years ago, we had very cold conditions here on Earth. However, we had more than 10 times as much CO2 in the atmosphere. So clearly CO2 is not a major climate driver. At least it wasn't a major climate driver then.
When we are in between spiral arms, it looks as if we are in a warm period called a hot house. And most of the ice is simply melted. There's no ice at all. When we are in the spiral arms, half the area of the Earth is simply covered with ice. And the changes in climate, are much, much more dramatic than anything we have seen recently.
I've been working almost all my life on issues related to environment. And of course, one of the biggest problems and issues was what was the climate and how the temperature of the seawater changed. And we worked on the fossils like this, called brachiopods. These shells record the temperature of the past oceans. When they form, they reflect the temperature of the ocean water because they build in the atom of oxygen. Then you could measure this proportion of oxygen, and you could get a measure of the temperature of the past oceans, and that means of the temperature of the Earth and climate. So when we can measure this, we would get a record of ocean temperature for 500 million years. When I look at the data, I realized that actually there were some oscillations in the general trend of temperature, and that those oscillations fitted quite well with what we knew from geology what kind of a climate was at that time. Working with the colleagues, we did an evaluation and statistical study of that, and we saw that there was some kind of a periodicity roughly of about 140 million years, switching back and forth between hot house and ice house. I suspected that the reason for this rough periodicity was something to do with the sky. But I was searching for it and couldn't find anything. So essentially I gave up. I didn't have an explanation.
Jan Weiser, he reconstructed the temperature using a geochemical record. And the difference between that reconstruction and what I was using is that Jan Weiser actually reconstructed the actual temperature. So he knew exactly how warm it was and how cold it was. So I emailed him.
One evening, I was sitting in my office working. Suddenly, an email popped up, and this was near Sharil. And he says, well, I may have an explanation for you. He was telling me that he was working on cosmic rays variability over the more or less the same time intervals, and that the variability in the amount of cosmic rays hitting the Earth over this time interval was more or less similar to the variation in those oxygen atoms or in the climate which we observed.
And so I find it fascinating. Two guys, an astrophysicist and a chemist, oceanographer, using statistical analysis, are working on the same problems from a different point of view, and they are double checking each other. So let's now look at this video now where Heinrich Svenmark puts it all together.
All the bits and pieces was done over nearly a year. So it's not like from one day to another you all of a sudden jumps up and says, fantastic, we got the result. It's not like that. It's actually hard work. Do you think? I mean, there's always a degree of uncertainty when you do experiments because you are constantly questioning everything you're doing, whether it's right and wrong. But we have been very, very careful, and we have done many tests on these ideas. So I think, I truly think that we have found a very, very important mechanism. And the mechanism was a big surprise how it actually worked. It's far, but I mean, this is 0.34 ppb. So it's very, very low. What we find when we mimic a higher flux of cosmic rays is that we actually produce more aerosols in the chamber. This actually means that cosmic rays are producing aerosols, and these are the aerosols which are responsible for forming clouds in the real atmosphere. Through our experiments, we have found a new form for atmospheric chemistry, which we think is responsible for the formation of new aerosols and therefore also for clouds in the Earth's atmosphere. And it shows that events in the universe are driving climate here on Earth to an extent that has never been understood before.
Notice the length of his beard. There wasn't a beard when we started the video. Then there was a bit of a beard, and as you watch, the beard gets longer. That's because he's sending his paper off to be published, and nobody wants to publish it. They don't want to publish it because if he's right, then all the government funding that they're getting dries up. Because if man doesn't cause climate change, why spend money on climate change research?
In the sky is really a result of this process that we have investigated experimentally.
And so what he's basically talking about there is they have been vindicated by the research, and but it took an awful long time for him to get scientific community to even acknowledge that. There's one other aspect that I want to spend time on with this video. Think of what happens to the Earth's ability to fend off cosmic rays if the Van Allen belt, the magnetosphere, is weakened. That is actually something that's going on. And in fact, one concern is that perhaps the North and South Pole are getting ready to flip. And so if the North Pole is up at the top and the South Pole is at the bottom, if they flip, then they'll go side to side, say from South America over to Africa. So watch this video and see what you think.
The galactic trigger, the dust and gas mechanism for superflares and recurrent nova, the evidence on the moon, the stories of our ancestors, the global nature of the disaster, all point to the sun as the destroyer. But is it a superflare or a micronova? And does it really matter? To look at this question, we will first investigate the recent history of magnetic events on Earth, starting with the one ongoing now. The key element in this overall process is one that has already begun to unfold again here, and the clock is ticking as we move deeper into the shift. We know that Earth's magnetic field has begun an acceleration beyond its normal wander, and coincident with that is the loss of field strength. Magnetic reversals as rapid as 80 years have been recorded in the paleomagnetic record, and we are already more than double that many years into the current shift. While moving more slowly than the record fast reversals, things have begun to intensify. The Earth's magnetic field is currently decreasing by approximately 5% per decade, with the north and south magnetic poles set to meet in the eastern Indian Ocean. While the north is moving much faster, the south has already left the continent of Antarctica. The timeline is on the scale of a few decades to 100 years, presuming things don't accelerate any further. Seem impossible? Well, these are the current motions, and that is not disputed. But this magnetic meeting point scenario also has interesting coincidences, and not a one of them is bright and sunny. First, this region was an incredibly interesting place a few years ago, until the data disappeared. All the information in this video is available for verification via the online buoy database maintained by NOAA. Ball Basin, just east of India, is now at the North Pole. The Pacific Ocean, just west of Peru, is at the South Pole. The only version of the catastrophe cycle that was classified by the CIA is also the only one that mentions the Indian Ocean and South America as being the next polar regions after Earth turns over. Again, Chan Thomas's version says that is exactly where the new north and south poles of Earth will be. You might also notice, for the electromagnetically and geometrically inclined among you, that from the new poles to those triangles and maximum and minimum magnetism points, we are forming 90-degree angles. For those who find it difficult to ignore facts lining up, that was 7, including real observation data, geomagnetism, and a sprinkling from the CIA. Now, let's take a step back. We have now come to a point where a considerable compounding of these pieces into a puzzle is required before moving forward. The topic of Earth's catastrophe cycle has been well understood for centuries, past the point of question to the search for a mechanism.
I decided that a magnetic reversal had an awful lot to do with the dinosaur extinction. And then the more I researched, I realized that magnetic reversals also, as far as I'm concerned, trigger ice ages, and that they return in a cycle, in a regular pattern that we should actually be able to predict.
So what is going to happen to us? For that, we look back past the current shift to the last one, the last few, actually. And few people have cataloged the repeating magnetic disaster in the last few decades, as well as Douglas Vogt and Robert Felix. Although there is some question as to the exact timeline of the events, there is a series of global disasters that involve major magnetic events on Earth, surge deposits from inundations of the sea, filled with the bones of millions of animals, and the deposition, thereafter, of incredible amounts of snow and ice. The evidence paints the scariest possible picture of the near future on Earth. Felix and Vogt have done the best job analyzing the last few great geomagnetic events. The last one was the Gothenburg event. It is believed to have occurred between 10,000 and 13,000 years ago. 40 years after its discovery, there is still new evidence being unearthed. mostly leaning towards the latter side of that scale. The data on the Mono Lake and Lake Mungo events is all over the place, and to a diligent observer, it actually appears that some of the researchers got those events confused over time, especially the ones in Antarctica. In reality, it was almost certainly two events, one nearer to the 24,000 years ago range and another closer to 35,000 years ago. The last Champ event is probably the most well-studied excursion, and it was a tremendous hardship on the biosphere, one of the worst we know of. Lastly, the Antarctic cores from Vostok do show another event in addition to the lake event about 35,000 years ago, and this one is about 60,000 years ago, which does allow us to find one more solid event before the data is mostly lost amid erosion and time and geology. And so if we consider the lake events at the two boundaries of that time data zone, we basically have an event slightly less often than once every 10,000 years. Whether it is an exact cycle or not, the 11 to 13,000 year range appears to be solid, and so about 12,000 years from the last one, and with Earth's magnetic field starting to shift already, and with only decades to go according to the math, less if things accelerate, there is every reason to believe that the long cycle timing and observable changes happening now are not coincidence, or at very least, you cannot presume it is a coincidence, at least not with what's at stake.
And so as we conclude that particular video, there's 3 points that I want to make. The first point is that certainly pockets of the planet have environmental challenges. Think of the LA basin where a kind of like a temperature dome is formed so that gases have a hard time of escaping, especially with the Rocky Mountains and so forth. And so it makes sense in those areas to have more strict environmental regulations. That just makes sense. China could help itself tremendously by cleaning up its own pollution issues, just as the United States did in the 70s, 80s, and 90s. So that's very clear. The second point is that the politicians who are looking to bilk the American taxpayer at the tune of billions of dollars basically see the opportunity to make money on a scam when the opportunity presents it. It would be much better if they would spend their time and their resources at looking at some of the issues that have been brought out in this video, as well as others that one could have looked at. And the third point that I'd like to make is if you're a young person and you're thinking about what your career might be, don't be like that Andrew Light person that I talked about in the climate change con job. Andrew Light is a consultant on environmental stuff with a PhD in philosophy. Today, you've seen videos of people who have actual scientific experience. Go into those hard sciences, make a career in looking at that, and help bring the truth of real science forward as opposed to pseudoscience dressed up with a lot of public relations fluff to make money for the elites at the cost of the American people. Well, I hope that you've enjoyed this video. I hope you'll visit my YouTube channel. It's Wise Jargon. There's the complete thing. You can also find me at YouTube/David Lantz, Lantz. This is a new channel that I've created off of that, so it's a little bit more difficult to find. Well, until next time, I hope that you will keep searching for ways to defend the American way of life. Until next time, thanks so much, and God bless.